Friends, this is your physics class. Today, first of all, we're going to word NCERT question on page number 118. In our last lecture, we have done inertia and mass. So, students, this exercise is based upon inertia. So, there are three options. Which of the following has more inertia? A ball, a rubber ball, and a stone of a same size. Which is more inertia? First of all, I want to discuss inertia is depend upon mass of any object. So, according to size, rubber ball and stone have a same size, but in case a stone has a more mass comparison to rubber ball, then a bicycle and a train, then a 5 rupee coin and 1 rupee coin. So according to these situations, a stone having more inertia because it has greater mass. A train will have more inertia than a bicycle because it has a greater mass. Then 5 rupee coin has more inertia comparison to 1 rupee coin. So question number 2 on page number 118. In following example, we're trying to identify the number of velocity of a ball changes. A football player kick a football to another player of his team, who kick the football toward the goal, and the goalkeeper of opposite team collect the football and kick it toward a player his own team. The velocity of 4 times when a ball player kick football to another player, when a player kick the football toward the goalkeeper, and third one is when goalkeeper stop the football, and D1 is when goalkeeper kick the football toward the own player of his own team. So student, explain why some of leaves may get disattached from a tree if we vigorously shake its branch. So that concept is related to inertia, because when we suddenly shake a tree branch, the leaves detach from the branch due to inertia, because leaves stay in a remain same state but branch in a motion. So that is the reason why the leaves is disattached from the branch. So question number 4, why do you fall in forward direction when a bus brakes to a stop, and fall backward when accelerate from suddenly from rest? So in moving bus, passengers are in a motion. When brake applied for stop, the bus come into position rest, but bodies turns to in a motion. So that's why passenger move forward when brakes apply. Similarly, when bus accelerate from rest, the body tends to rest, but bus moves in a forward direction in a motion, then a passenger moves backward direction. So these are the NCERT exercise up to 1 to 4 on page number 118. So students, further we are going to start. Student, in our previous lecture we read about Newton's first law and inertia. Because inertia and a Newton's first law are similar, because there are a singular definition about Newton's first law and inertia. Whenever we not applied force on any object, the objects remain in a same state. So this is the Newton's first law. Then After that, inertia is a tendency of ability of any object to stay in a same state whenever we not applied on a force on this object. So then further we going to start law of motion, second law. So I am going to share a video clip. You have to listen carefully and watch this video. After that, conclude of Newton's second law.
We have learnt about Newton's first law of motion. It states that an object remains in a state of rest or of uniform motion in a straight line unless compelled to change that state by an external unbalanced force. Now let's understand Newton's second law of motion in action. Here is a karate player ready to break a brick with her hand. At first, she slowly moves her hand on the brick. If you observe closely, here the rate of change of momentum is very less, due to which there is a very less force applied on the brick. So, the brick doesn't break. Now, she moves her hand very fast on the brick and it breaks. This is because the rate of change of momentum was high. So, the force applied became high too, causing the brick to break. The phenomenon of how the rate of change of momentum increases the impact of force on the brick, which in turn breaks it, can be explained by Newton's second law of motion. It states that the rate of change of momentum of a body is directly proportional to the applied force, and it takes place in the direction in which the force acts. Now, let's see if the force applied on an object is proportional to its rate of change of momentum. When a batsman hits a ball with less force, then the rate of change of momentum is less, causing the ball to slow down and finally stop. On the other hand, when the batsman hits the ball with full force, the rate of change of momentum becomes high, causing the ball to move faster in the air, sometimes resulting in a six. So today we learnt about Newton's second law of motion. Now action around you.
So student, in this video we have learned about second law of motion. So how do we define second law of motion? That is, change in linear momentum or change in momentum is directly proportional to force applied on it. So if force is greater and when we force increased, then in case momentum is also increased because they are directly proportional to each other. So after that we going toward mathematical formulation of Newton's second law. Student, first of all, initial momentum. Momentum is defined by P. So it is a symbol to define a momentum. Momentum is defined by or denoted by P. So what will be initial momentum P1 of the object? Imagine object M with initial velocity u. It's uniformly accelerate with v velocity in time t. Application of constant force is F throughout the time t. So what is the momentum? We know that momentum is directly proportional to force. So momentum is equal to mass into velocity. So u is defined the velocity. This is the what will be final momentum? That is P2, which is mass into v is final velocity. So according to change in momentum, change means difference. Difference is final momentum minus initial momentum, that is mass into v minus u. So student, at the last the change in momentum is mass momentum upon time. So mass into velocity upon time. So force is directly proportional to momentum. According to Newton's second law, we applied a formula: force is directly proportional to momentum. So we know that v minus u upon t is equal to acceleration. So according to this formula, force is equal to mass into acceleration. So that is the final formula. K is the constant, proportionality constant. So what is the Newton and what is the unit of force? We know that mass is in kg and acceleration is meter per second square. K is equal to 1. So kg meter per second square is equal to Newton. So there is the SI unit of force is Newton. So student, if you have any queries related to second law, inertia and first law, you have to text me anytime. For your reference, you have to read your concept number 19 on SB 19 and SB 20, which is defined formula on Newton's second law and first law. Thank you. Happy learning.